In this problem, you have a piecewise function with three pieces: blue, purple, green. We talked about how there are restrictions. There are these boundaries. Look for the ones that have the same numbers over here. -2. When I draw this vertical line, class is an asymptote. No, it's just a boundary, a good visual to help you draw the graph. My other same number is 1. Yesterday we learned how to graph them from the equations, looking at their characteristics. But let's just say you don't know how to graph it. Well, you can just use your table of values. In my calculator, if I put in this as function 1, 2, and 3, so -x, x minus 3, and x squared minus 2. Now, if you notice, in my graph, I'm going to have 3 sections or 3 pieces. 1, 2, and 3. For this purposes, I'm going to change my table set. So I'm going to press second window. What did I just say, class? And I'm going to change it to auto. Doesn't matter what number it starts on. And table changes by 1 is good. So now if I go to table, class, how do I get to table? Second graph. And I'm going to scroll up to maybe about -5. And you can just copy down those numbers and it helps you graph. Does that make sense? So for the blue, that's my first one here. -5, 5, -4, 4. Just writing down some values. -3, 3. And once you have a good idea of what the graph looks like from that, then you don't actually need to copy all those numbers, do you? For the second graph, that's here in my calculator in red. And you can even cheat a little bit. You'll recognize that my graph has to be between the numbers of -2 and 1. Do you see that? So you can just get the numbers between -2 and 1. And it's okay if you go a little bit more just to see what the pattern looks like. So a -2, that would be -5, -4, -3, -2, -1. And my function in green, it is a quadratic to the power of 2. I want values that are greater than 1. So you can choose 1, 2, 3, 4. So I get -1, 2, 7, and 14. So if you graph these now, everyone say pencil. Let's graph it with pencil. -5, 5. Left 5, 1, 2, 3, 4, 5. Up 5, 1, 2, 3, 4, 5. -4, 4. -3, 3. -2, 1. -1, 1. 0, 0. And basically that's from slope-intercept form, right? Yesterday we learned that you could have just done -1 over 1. And then plus 0 is your y-intercept. So you can see that. Down 1, right 1. Do you see how that? And it'll still be on this line. Yesterday we learned to first graph it. And then we're going to go back and erase. This one says values between -4 and -2. I missed a boundary. This one says -4. So between the points -2 and -4, there's my graph. Class, are these open or closed? Closed. Let's make some solid circles here. And really all I need is a graph right here. because my x values are between -2 and -4. And I can erase everything else. On to the next piece. In purple, we had these points here, -2, -5. -1, -4, 0, -3, 1, -2, and 2, -1. So here's my line. And I only want it between -2 and 1, which is between these two boundaries here. So we'll be erasing over here and over here. And this one says a closed circle and an open circle. So at -2, a closed circle where it touches the boundary. 1 is an open circle. And I can draw my line here. Let's erase everything else. And the last piece is a quadratic. So 1, -1, 2, 2, 3, 7, and 4, 14. So something really high. What? 2, 3, 4. 2, 4, 6, 8, 10, 12, 14. Something really high up there. So my graph's probably going to look something like this. We did that one in green. Open or closed circle? Closed. So let's review. We're graphing 3 pieces, and the pieces never overlap. Notice between these 2 yellow lines, there's only one graph. One graph. One graph. We don't see a blue graph or purple graph underneath the green one. They're in their distinct little areas. Today I showed you a different variation of getting these by just using a table of values. So you don't even need to know how to actually graph these by hand. You can just use your calculator.